Hello students, you are on to Dr. OJ's tutorial class. In this video, we shall illustrate cubic functions with relevant example. Don't forget to click on the notification button so that each time I upload a video, you'll be duly notified. Now, in this example, we are asked to sketch the graph of f of x is equal to x cubed minus 2x squared minus 5x plus 6. Now, we follow the steps we mentioned in the previous video. To start with, let's find f of 0. What is f of 0? Let's find the value of f of 0. So f of 0 will be 0 cubed minus 2 0 squared. We are multiplying 0 squared by these 2 here. That is, you put x to be 0, then plus 6. So by the time you find this, 0 cubed is 0 minus 0, everything is 0 there, everything is 0 here. 0 plus 6, you have 6. Fine. So that means that the maximum point for that particular graph is going to be 6. You will see as we go on. Now let's now find when f of x is equal to 0 itself. F of x is equal to 0. That is, when x cubed minus 2x squared minus 5x plus 6 is equal to 0. And to do this, we need to find a way of reducing this cubic function to a simpler function. That is, it's a cubic function like this. We need to find a way of reducing it to quadratic functions as well as linear functions. And to do that, we have to use trial and error method that we learned previously in factor theorem. Okay, so let's try when x is equals to 1. If by the time we put x equals to 1 into this equation, if we are able to get 0, that means x equals to 1 is a factor. F of x equals to 1. Put f of x equals to f of 1. Put f of x equals to f of 1. Let's check. So we have that is by trial and error method, by trial and error method. So if it doesn't work, we try another value of x. Okay, now let's try. So we have 1 cubed minus 2 multiplied by 1 squared minus 5 multiplied by 1 plus 6. So that will give us what? This will be what? 1 minus 2 times 1 squared, that's 2. Then minus 5 times 1, that's 5. Plus 6. I think that will give us 1 minus 2 is minus 1. Minus 1 minus 5 is minus 6. Minus 6 plus 6, that's 0. Fine. So that means x is equals to 1 is going to work as our divisor. X equals to 1 is going to work. So we are now going to use x equals to 1 to divide the function so as to reduce it. Okay? Now, quickly we do this. Since f of x equals to f of 1 is equals to 0, then x is equals to 1 is a factor, and x minus 1 is a divisor. How do I get x minus 1 from here? Since x equals to 1. So by the time you bring 1 here, it becomes x minus 1 is a divisor. So we divide. Let's divide the function. X cubed minus 2x squared minus 5x plus 6. Then x minus 1. So x in x cubed, that's x squared. This divide x cubed by x, you get x squared. Now expand. X squared multiplying x minus 1. X squared times x cubed. Then minus 1 times x squared minus x squared. So what next? You subtract this from this. We have learned this before. By the time you introduce minus sign here, this one will change to plus sign. Okay? So x cubed minus x cubed, that's 0. Minus 2x squared plus x squared, that's minus x squared. Then you bring down this, minus 5x. So you pair it like 2, 2. Okay? Now, divide minus x squared by x, that's minus x. Okay? Now, minus x times x, that's minus x squared. Minus x times minus 1, that's plus x. Okay? Now, as we did previously, you subtract the one down from the one up. So by the time you introduce minus sign, this one becomes plus, this one becomes minus. So minus x squared cancels the plus x squared, that's 0. Then minus 5x minus x, that's minus 6x. Then you bring down plus 6. Now divide minus 6x by x, you have minus 6. So multiply minus 6 by x minus 1, that's minus 6 times x is minus 6x. Then minus 6 times minus 1, that's plus 6. So you can see that everything is cancelled there. What you have here is what you have here is what you have here. So it will be cancelled. So that means we have reduced the function given to us to what? A quadratic function using x minus 1. So our function is now what? Our f of x now, the new f of x now is what? X minus 1, the divisor, then with the what? The value obtained as quotient. Sorry, as our solution. X squared minus x minus 6. Okay? Now, let's now equate this f of x that we have just gotten now. We want to find the zeros. We want to find the zeros of f of x. How do we get the zeros? Now, to find the zeros of f of x, to find the zeros of f of x now, we have each of this function equated to 0. So x minus 1 is equals to 0. Then and x squared minus x minus 6 equals to 0. Now this one is clear. We can easily get the zeros of this. Now this one is a quadratic equation. That means we still have to factorize this one to get the zeros of x there. So we're already familiar with factorization method. We multiply minus 6 by x squared there. It gives us what? Minus 6x squared. So we find the factors of minus 6x squared. That we fit in when we are going to have minus x. And when we multiply, we still get minus x squared. So we can think minus 3x plus 2x. Yes. By the time we multiply minus 3x by 2x, multiply now, we get minus 6x squared. You multiply that pair, you get minus 6x squared. And you add them together, you get what? Minus x. So we have x squared now minus 3x plus 2x minus 6 is equals to 0. So what is common here? X into x minus 3, plus 2 into x minus 3 is equals to 0. So we have what? X plus 2, x minus 3 is equals to 0. So now to find the zeros of this x now, just what? From x minus 1 equals to 0, we have what? X is equals to 1. From x plus 2 is equals to 0, we have what? X is equals to minus 2. And from x minus 3 equals to 0, we have x equals to what? 3. So the zeros of x here, of this function, the zeros of the function f of x is what? 1, minus 2, and 3. So now we sketch. The last stage is to sketch now. The last stage is to sketch. We have 1, minus 2, and what? And 3. Let me write that down. X equals to what? 1, minus 2, and 3. So now we sketch. It's as simple as that. Let's see how the sketch will go. Let's see how the sketch will go. Let's see how the sketch. Just try this. Try this. Now indicate those points. First of all, this is the what? The center of origin. That is the origin of the graph. X equals to 1. We come here. Positive value. X equals to minus 2. Will be somewhere. Let's say this is minus 1. The minus 2 somewhere here. And x equals to 3. The what? Let's say this is 1, 2, and 3. Okay. Now don't forget the zeros of when x is equals to 0, in the function we have 6. So that is f of 0 is 6. I hope we're getting that. Okay. So let's put our 6 here because f of 0 represents what? Y. So our 6 is somewhere here. Okay. So now you can see that the sketch is what? It's very, very straightforward. So what you just need to do what? Join the points. Join the points. Join the points. Join the points cleverly. Like this. Like this. That's all. That's all. So that's it. So we have sketched the graph of that given what? That given function. Now, the signs of the functions for the other values of x are the signs of the functions, for other values of x. For other values of x are, let's look at the signs of the function. Now you can see, let's say, suppose we draw this as a point there. Now we have minus 2, we have 0, this one will be minus 1, obviously. Now we have minus 2. Let's extrapolate minus 2 up. Let's extrapolate it up because we already get that in the question and in the solution, in the graph. So we have 1 is there, extrapolate it up because 1 is in the graph. Obviously we have known that. Then we have 3. We have 3. You can extrapolate it up. So extrapolate it up already. Now, obviously, you see that between minus 2 and 0, we have a positive component. So this is positive here. Positive. It's going to be possible that is between the 0 and minus 2. Sorry, it will be here. Positive value will be here. Now, between 0 and 1 is also positive. Here, it's also positive. And between what? Between 1 and 3, what you have is negative. You can see that. Between 1 and 3, that is what? Negative. So, now the last stage is, but obviously now, there's another way of showing this. So, sorry, there's an error here. Between 0 and 1 is minus because it comes down. The graph comes down here. It comes down here. And now, between 3 and others, the graph rises. It rises, it falls. So sorry, it rises here. That's why you have between minus 2 and 0, the graph rises. That's a positive sign. It comes down here. Sorry, that was a slip of tongue. Between 0 and 1, it will minus. You can see minus, and it rises again here. So that's after 3, it rises. So between 1 and 3, it is negative. Let me come back again so that you understand this. Between minus 2 and 0, notice the graph rises. That it rises rather. We have a positive sign. But between 0 and 1, we're talking about values of x, it comes down. You can see 0 and 1, that's negative. Now, between 1 and 3, it's also negative, it comes down. You can see. But when it gets to 3, it moves up again. So that's what we mean by that. The sign. It's minus, plus, minus, and plus. So I think we are through with that. Now, also, as x tends to infinity, also, just to conclude, also, you can write this, also, as x tends to positive infinity, f of x is also what? Tends to positive infinity. Okay? And if your x tends to negative infinity, the same thing happens. X tends to negative infinity, f of x will what? Why? Because remember we said the range and domain of cubic function is always set of real numbers. So on this note, we have come to the end of solutions to this particular problem. So don't forget to click on the notification button so that each time I upload a video, you'll be duly notified. Thank you.